Hey everyone, welcome to the stream. Running a bit late tonight, but anyway. So yeah, let's continue working on audio. So I believe, let me see here. I think this was last time, right? Oh no, that's it. I did some, or did I just submit on the Friday? Yeah, I think I just submitted on the Friday. So basically, last week, fix output volume curve. Oh yes, that's right. So last time we had worked on implementing the noise generator, and then that's it. And then on the next stream, we worked on doing the whole volume envelope. That's it. We implemented the volume envelope, and what we had found was it wasn't quite working to spec, and we spent a really long time looking into that. Hold on a second. Make sure everything's muted here. Okay. Yeah, so what we found out was that actually everything that I had implemented and understood from the documentation was correct, but the way I had implemented the way that the output volume is applied was incorrect. Yeah, we found in the documentation that the volume is non-linear. Let me see here. Yeah, I seem to have like lost. Oh no, it's here. That's it, it's here. We found out on this web page here that actually has more detailed information about the 8910, the AY3 8912 in our case, audio chip, that the amplitude, the volume is not applied linearly. So like we have these values from 0 to 15, whereas 0 is like no volume and 15 is max. And I was just basically doing a linear interpolation, right? I was just dividing the value by 15 and using that as a ratio to scale the volume. As it turns out, the volume isn't supposed to be scaled linearly, and here they give the function, and basically the curve is the square root of 2 to the power of 15 minus whatever value we get. We take that and we divide that from our max value. So in our case, it's 1.0, and that's basically what we implemented here. Excuse me. And then that actually made it sound correct. Now, along with that, let me see here. Fix output volume curve. Then we implemented the volume envelope. And then there was another thing that I found out while reading this page. There seems to be like a lot of very interesting information in here. So one of the things I found out here was that if both the tone and noise are disabled, that's right. There was this question I had about like, how do we treat both tone and noise on the same channel? And the way I decided to do it was, if we have 3 channels and each channel can have 2 things playing on it, a tone and a noise generator, then I guess that's total of 6 values, which means like, and if each one of those can produce a value between 0 and 1 or 0 and 1, I would just basically add the values and divide everything by 6. And that's what I was doing. But that turns out that wasn't actually correct. Let me just bring up a diff here. So as it says in this document, if both tone and noise are disabled on a channel, then a constant high level is output. And that's actually something we have to do. But if both tone and noise are enabled on the same channel, enabled, then the signals are ANDed. The signals aren't added, which is what I was doing. I was adding, and you can see it here. If the, let's see here. If the tone channel is enabled, we add its value. If the noise channel is enabled, we add it. This happens 3 times in a loop. See, here's our 3. And then at the end, I was dividing by 6. Instead, what it says is you're supposed to AND them. So what I do now is I say if both tone and noise are enabled, well, I grab their values and AND them. So that basically will either be a 1 or a 0. Otherwise, if it's tone, then we grab, if only tone is enabled, we grab its value. Otherwise, if noise is enabled, we grab its value. And then we, at the end, we just divide by 3. And this actually sounds quite a bit different. When we have both noise and tone, which is the case, for example, when we fire bullets in Mindstorm, the sound isn't exactly the same as what we were getting before. Before, you could always hear both the noise and the tone, even when one wasn't playing and one was, whereas now you only hear them when both are high. So it totally changes the sound. So I did this, and that actually works. And then I did something off time, and I'm probably just going to merge this in or just move to it. This was kind of interesting. So I was discussing with my good buddy, who actually is often on the stream, Raptor of Axis, who, by the way, has his own stream where he does hardware modifications. He's been working actually on modifying and improving his old what's it called? His Kinesis Advantage keyboard. So actually, let me give a link to his page just while I'm talking about it. So yeah, so this is. Oh, and he's actually streaming me. That's kind of hilarious. But anyway, Raptor of Axis, and he has his own videos. Although right now I think that they've been deleted here. But he has a YouTube page, just like I do, where he keeps all his. Here we go, YouTube here. He keeps all his videos. So I'm going to digress a little bit here because I just want to plug my buddy. He's really super smart and has really interesting stuff here. That's it. So you can see here he's been working on retrofitting, lots of videos. He's been working on retrofitting Cherry MLs into a Kinesis Advantage. So super interesting project. He's basically using his 3D printer to print parts and has a really interesting process. I highly recommend it if you're into hardware. So yeah. So anyway, I was talking to this guy, to Raptor, and I was asking him like about this thing that I found weird, which is this whole notion of working with values from 0 to 1 in the audio spectrum, and how, like, you know, and I'd shown this on previous streams where I would look in Audacity at the audio curves, and everything was in the positive spectrum, and I'm like, this doesn't seem right to me. And sure enough, as he explained to me, no, that's not actually right. And that, you know, if I've decided to model my audio chips to return values between 0 and 1, what we would want to do is treat 0.5 like the center point as the no sound, and that when scaling by amplitude, I need to scale around the 0.5 and not around 0, which is what I've been doing. And so I actually have a fix here that does exactly that. So let me show that. Let me just ignore the floor call here because that's actually unrelated. This kind of mixing two changes. But the real change I'm talking about is right here. So in here, when we have no volume, instead of returning 0, I'm going to return 0.5 to mean we have like no sound right now. And then here's the key. We get a sample, right? And the sample is going to be 0 or 1. And we have a volume, which is a ratio from 0 to 1. And what we do is we take our sample and we bring it down by subtracting 0.5. So that brings it into the minus 0.5 to positive 0.5 range, multiplied by the volume, and then shift it back up. So this gives us basically a correct scaling and basically applying amplitude correctly around the center. And with this change, we actually get audio that is correctly centered around 0 and sounds actually correct. What I was getting almost sounded right, but when there was a shift in amplitude, the change in amplitude was not, it was kind of warped. We were getting like a, you know, much louder than we should or much quieter than we should during those ramp ups and ramp downs. So it was not scaled correctly. So let me actually grab this change here. I'm gonna do it a little bit differently. So I want to do cherry pick that, but I just want to start with this part here. or actually, let's see here, unstage that. That work? Okay, so here, I'm just gonna copy everything. So make 0.5 the center, no audio, of source samples, and apply amplitude scale correctly around this center. And then the other thing, and that's this flooring here. Oh, and actually there's something wrong here. Hold on a second. Yeah, I don't even know how to fix that. Hold on. Reset. So I meant to take only the bottom here. Yeah, that's it. All right, and then next is this fix here. So actually there was what was interesting is that once I centered it around 0.5, there was a little blip, like a little bit of a sound that when there should have been none. In fact, we can, you know what, I can actually make you hear that right away. Although, wait, I think I have that fix. So that's not gonna work. Let me reset this. Okay. Okay, so first let's hear what this would sound like. And I'm gonna do a capture and we're gonna take a look. Is this audio being captured? Oh, let me stop the music. So you can kind of hear this like high-pitched buzzing at all times. It's really obnoxious actually. And if I open up Audacity, we'll just take a look at the signal and you'll see what's going on there. Discard projects. Yeah, that's fine. So let's do an import of raw data and let's grab this here. And this is going to be in float. It's 32-bit float, little endian, yeah. Is it in 32-bit float? Maybe I'm wrong. No, it's not. It's actually, yes, not in float, that's true. It's 16-bit, sine 16-bit, yeah, that's right. Okay, so here like, that sounds kind of right, you know, but you can hear there's a buzzing in here. You know, there's all supposed to be zeros here. And if we zoom in, we can see that it's clearly not zeros. There's definitely a pattern in here, you know? Like, look at that, right? And it's clearly periodic as well. As it turns out, after a little bit of debugging, I figured it out, and it has to do with the resampling that I'm doing here in the PSG. If I go to resample, no, it's in here, resample. So basically I have a mistake in here where I'm accumulating samples until I have enough samples to output at the output sampling rate, which is 44,100, which is not the same as the source sampling rate, right? So I have here how many CPU cycles per audio sample must pass. Once I immediately have passed that, I go ahead and produce an output sample by taking the sum of all samples so far divided by the number. And that's almost works. And the reason why it almost works is that num samples here isn't an integer, it's a float. And the reason why it's a float is because I need to keep track of the error. And what I'm talking about is the fact that my number of samples here will surpass this, and this value here is not some nice round number. It's not like a number of samples is, this is 5, and once I have 5 samples, I'm good. This is actually a value of, I forget now. It's some floating point value. We can actually just look in the debugger. So you can see here 34.01, right? So it's a small fraction, but still what ends up happening is that once we've accumulated enough samples, so here we have 35 samples, that's more than 34.01, right? we end up with num samples here. What I do is I subtract the 34.01, and we end up with a 0.98 this time, so that the next time we'll get there a bit faster, right? The next time we come here, our num samples now is 34.98. Anyway, all that to say is my sample sum is always a round number because I'm adding these samples, but I'm dividing by a non-integer version of num samples, and that actually isn't correct. So what I do is I need to turn this into an integer value. So actually, I guess I could just do it this way. I ended up using floor because then I don't have to worry about casts back and forth. So yeah, I think I'm going to stick to that because I think it's not stood floor. Although I don't know, can I use stood floor? Do they even exist? There's such a thing? Looks like it. Although that's in... Does this end up in stood? I don't know. If I include math here. Let me see. Is it, I guess, no, math.h or cmath? Yeah, cmath. Yeah, that looks like it works. Why isn't it going to floor? Current document. Weird. Okay. Once we put this in, now we're getting a correctly computed sample, but we continue to accumulate our error as before. So this actually should remove this this weirdness. Let me see. Take off our breakpoints. I'm just going to kill this so we can take a look at the difference. So now we have this signal here, and you can see that it's completely clean, right? It's nicely centered around 0 here. There's no noise. So if we solo here, as opposed to hey Moosey boy, how's it going, man? So what's the difference between a normal wave and a raw? Actually very little. The raw format is just missing the wave header, and I actually have a to-do on my list to make it a wave file so I could stop selecting things. Output wave file instead of raw file. It probably will take me like just a few minutes to do, and I just keep not doing it, but that's really the difference, you know. Like if we look at wave file format, I don't know if we can see here. So the top level definition of a wave is format, fact chunk, queue points, playlist, associated data, wave data. Yeah, so like, it looks like it just has some header file. Let me see if there's like a simpler one here. The canonical wave file format. So it's got some stuff here. Yeah, I don't know. Some stuff with chunk sizes, sample rates. Basically, you just got to store. You can see like the information that we really care about. Yeah. Basically, we want to figure out the chunk size. And then here, you know, we're interested in this kind of stuff here. Sub chunk size, audio format, number of channels, sample rate. And I guess we have to be careful with stuff like alignment. And then after that, we put in our data with all the samples. So yeah, maybe not as simple. Yeah, maybe it's not 3 minutes. I think I'm you know, over or underestimating it. maybe probably with a little library, it would be take no time at all, clearly. But anyway, whatever. Like, I know the formats, and really this is just for debugging purposes, right? So it's not a big deal. Anyway, so this works, and we can actually, we'll commit this because it fixes the problem. So I'll just say here, fix resampling to remove, I don't know, periodic noise. Now, I was thinking about stuff to do, and the fact that I have to do this kind of code, let me go back to the code here. I'm fine with the resampling part, but the parts that kind of bother me is this code has kind of become a little ugly. The whole like sampling a channel, and if the volume is 0, returning 0.5, and this whole like subtract 0.5 to scale by volume and add back 0.5. And all of this is really because, all this is really because in the end, I'm working in a 0 to 1 range. And as it turns out, another thing I discovered was in the audio, the SDL, what do I call it? Audio driver, yeah. It turns out that the floating, like float 32 format for audio actually expects things to be in the range of -1 to 1, not 0 to 1, which is what I thought. And so I've got this like interface where I pass samples in the range 0 to 1 here, and then I go and remap them to -1 to 1. And it turns out that all of this is kind of just, you know, a bunch of scaling and stupid stuff that I'm doing. And what I should do instead is, I think, you know, rather than producing values in 0 to 1, just produce them in -1 to 1 to begin with. I just think that would make things a lot simpler. For one, I could go back to returning 0 here. Secondly, if I got -1 to 1 values, I could literally just scale it by the volume because it would just work. Because my center would already be 0. So that's something I could do, and I don't think it would be too much work. It just means things like, right now my chips, you know, have values that oscillate between -0 and 1, and I would just change them to basically return values between -1 and 1, and I think that would pretty much be it, and undo these changes there. I would change my audio driver then to expect -1 to 1, and you know, honestly, I'm going to stop using sine 16 because there's no point. Just switch to F32, and the conversion, the remap, would just return ratio because it's already in the right place. And that's it. So actually less work overall and simpler to understand. So Moosey Boy says, about what you said earlier, what could be the reason they didn't make the amplitude linear? So I don't know. When I asked my buddy about that, he said that it's possible that something about like older hardware and I don't know, the way the hardware would be made. I don't know. I didn't quite understand. Like maybe it was easier to keep the chips really simple, but then just have some kind of chip that would do this kind of non-linear ramping of the volume so that we get, I don't know. Actually, you know what? I'm not gonna really expand on that. I don't know enough about hardware to explain why. If somebody actually does, somebody is like more of an expert in audio hardware, and you know, why would the Vectrex do this? I don't know. It doesn't really explain the why here. It just says the what, right? The volume is non-linear. Below formula does comply with the PSG datasheet. So there is something here about the datasheet, and maybe we'll find that in here. There was something about amplitude. Let me see. Let me see here. I feel like there was something about that in here. Maybe it was lower. was after all this. I think it's here. Okay, yeah. So since the primary use of the PSG is to produce sound for the highly imperfect amplitude detection mechanism of the human ear, the digital to analog conversion is performed in logarithmic steps with a normalized voltage range of 0 to 1 volt. The specific amplitude control of each of the 3D digital to analog converters is accomplished by the 3 sets of 4-bit outputs of the amplitude control block, while the mixer outputs provide the base signal frequency. Figure 9 illustrates the DA converter output, which would result in noise and tones if noise and tones were disabled and an envelope-controlled variable amplitude were selected. So this is the envelope only, noise and tones are disabled. So they're showing from 0 to 1 volt here. They're showing the logarithmic steps for each of the volume values. So their claim, the claim that they're making is that it has to do with the imperfect amplitude detection mechanism of the human ear. So I guess the idea is that the way we hear the sounds is we hear high, like louder sounds more clearly, more distinctly than we hear lower sounds, or something like that. You know, low volume sounds, I should say. Or maybe it's the other way around. Like we can, small steps in low volumes can be heard by the human ear, but once we get to higher volumes, we need larger steps in order to discern them. I don't know. Does that make sense? This is really though like, you know, acoustics and audio, and I'm really not a pro. I don't know much about that stuff, you know. But I do know that once we put in this kind of ramping, it totally sounds right. So, you know, let's do a little bit of a, let's show this off a little bit, right? Let's actually play around a bit, and we'll see that the emulator is sounding pretty good. And I know if you don't probably have a basis for what it's supposed to sound like. So this is Mindstorm, which I've been playing for a long time. Hopefully it's not too loud, or I hope it's loud enough. Let me know. Thanks, Moosey boy. I'm glad it's okay, so this, you know, this is only so much sound we're going to hear out of this one. One that has a constant sound, almost a music, if you will, because no games really have music while you play. Scramble here has a constant sound, an oscillating sound. So you can hear when I don't fire, you can hear there's a oscillating sound there. So that's scramble, and that's pretty much how I remember it sounding from my actual Vectrex. What else is there that's interesting? So one interesting one is ripoff, and the reason why it's interesting is that in this game, as you lose barrels, there's a tone that goes higher pitch, and the idea there, of course, is for you to get more and more nervous because the pitch is going higher as you're losing. So they use so here there's like a tone, right? Let's say I let one get stolen. See, now the tone is a bit higher pitched. In this game, you're supposed to protect these things. we'll go to the next wave because they're faster. Are there any ROMs that aren't working yet? So there are ROMs that aren't working. Very few though, and I think the ones that are not working. Hold on a second. I just want to hear. And there we go. Yeah, so I have a page where I kind of kept track of all the ROMs that are working and the ones I've tested. So all of the released ROMs are working. Some of the later versions of those ROMs, which I think are like mostly modifications and hacks, some of them don't work, and I don't know if they actually do work. I've tried some of them on other emulators and they didn't work much more there, so probably they just don't work. I don't know. And then there are some homebrew ROMs. Most of the ones I've tried seem to be working. So I mean, I think I've pretty much covered. I think I have a good CPU implementation, and I think I've got most of it covered. There are still a couple of things that I have to fix. Like there are a few modes in the VIA that seem to be invoked, like set. I don't support those modes, but I don't think games actually make use of them. I think it's more like incidental, you know, like a game will... Sorry. I think games will actually like, you know, set some bytes and then that'll turn on this mode that I don't support yet. But that it actually doesn't get used. So I think what I'm going to do is I think I'm just going, because I have these assertions when that happens, like, and it just kind of stops everything. I'm going to do the same thing that I do right now for what I call undefined behavior, where I have a way in my, I can actually show it here. So if I break into my debugger here, right, I have like a way to say option errors, and I can say ignore, log, or fail. Right now it's set to ignore, so when they occur, nothing happens. If I say log, it'll start spamming out to the log, and if I say fail, then it'll actually stop. I want to do that also for assertions, which I'm not doing right now. And then that will basically, I think, eliminate pretty much all the current problems that I have, and I think most ROMs will just work. And if they don't, well, we can turn on the log or fail and see what's going on. So I just need to treat, because I treat those two things differently in my code. So if I look for like assert, this is what I mean. Like I have these assert calls like this, and I think, yeah, so I have these assert calls, and specifically in the VIA, if I look for asserts in here, stuff like this, you know, expecting DDR for A to be either all zeros or all ones. This happens sometimes, and I think it's a mistake when a game does it. I don't think they mean to do it. So it's these things here. So rather than actually stop, I just want to ignore them or log them. It's just like I do for my undefined behavior. The sound sounds pretty much spot on from what videos I've seen. Thanks, Moosey Boy. I think, yeah, I mean, like I have the Vectrex and I played it a lot, and to me it sounds right. I'd have to like take it out and really listen carefully and maybe record it and just try to see. It would be awesome if I could get like digital recordings and really look at it to like look at the timings and stuff. It's possible that, you know, I have some slight mistakes in timing. It's very possible, but you know, overall I think it sounds pretty good. So let me go back here to my to-do. So I have here a couple things for audio. Replace divider with timer. That's gonna take no time at all. Source samples, yeah, this is something we were talking about just before. Volume control, I'd like to maybe offer a way to control the master volume. That's not really difficult. CPU direct sample support. So yeah, this is like, actually maybe I'll move this up because I'd really love to get this working. Oh man, Moosey Boy, don't worry about it. You can interrupt me as much as you like. That's actually what I love about streaming, you know. If I don't want to be interrupted, I've said this before. If I don't want to be interrupted while working, I don't think I'd be streaming, right? I just work on my stuff quietly without people watching. But I actually love the the back and forth and the questions and all that. So by all means, yeah. So I'd like to do this. So there are some games that actually have samples in them. The CPU basically just sends samples directly, and I'd love to support that. So I don't have that supported yet. I don't think it's going to be hard, but I don't know. I've never done that before. But I think it literally just sends the samples directly that have to be played. So I'll have to look. But just to show you what I mean, Vectrex Spike. No, Spike, yeah. So let's see if we can hear it. It's quite famous for the fact that there's speaking in this here. And there you go. So that's what I mean. Those digitized voices that we heard. I hear it again. It's pretty funny. So I'd love to hear that. Right now when I play Spike, of course, we don't get those sounds, right? Like, continue here. Spike. And there you go. Missing those beautiful digitized voices. So yeah, I'd like to get that working. And I also wrote output WAV file instead of raw file. We'll see about that. And before I forget, treat asserts similar to undefined in debugger. Allow to ignore log fail. I'll just put ignore log fail. So I'll take a look at that. Okay, so let's just bang out this replace divider with timer bit. It shouldn't take too long. Okay, so it's this thing here. Set period. Yeah, so one of the differences here is setting the timer here sets the period. Setting the period will just, where is it? It does a reset time, so that's the same. Okay. That should be fine. So let me comment this out. This becomes a timer. Call it reset here. So it's reset. Okay, it's because I don't have a reset here. But I think instead of that, I can just do assign like that, and it'll just reconstruct the timer. Although no, that won't put the 16 we want. So maybe I will put, whoops. I'll just expose the reset time. What else? Clock. That should be it. Why the sad face, Moosey boy? Oh, yeah, sorry, I missed that. Missed the cue. Yeah, so this looks like it's still working. Okay, well, see, that wasn't so hard. Replace divider with timer. All right. Okay, so let's look into this direct sample support. So I think I'm going to have to take a look at what kind of values I'm being fed. So what it said here in the document, let me just get that back up here. Here. It was not here. It was up here somewhere. No. It was, yeah, it was this document that we were looking at. Yeah, this. So it says digitized samples can be written to the volume registers. Directly to the volume registers. When doing that, it's best to switch the channel to constant high level by disabling both tone and noise. Another method would be to set tone frequency to 0001. The resulting frequency is too high to be audible, so the high-low levels sound like a constant half level. So it's written to the volume registers. Interesting. Oh yeah, there was something else that I wanted to do. Let me just do it now because this keeps kind of annoying me. So here I have noise generator control. I'm just going to call this noise generator. And then here I'm going to call these tone generator. See, now it's going to just map much more directly. Yeah. Oh, I was a bit too, let me see here. Still want tone channel, not tone generator. So these go back, these go back. Okay. So have you tried enabling low latency streaming? I did, and you know what, I should do it again. So I had enabled it and then had ended up disabling it back before I was a affiliate, because I had some of my viewers complaining that on their lower quality, lower quality connections that they had, like if they had lower bandwidth capability, my 1080p stream would just constantly be buffering for them. And so I decided to go back to the lower latency, the higher latency, like the default, because that was working better for people like that. But now that I'm actually an affiliate, I think that you can actually choose which quality you want for the stream. So I could totally go back to that. You know what, I'll make a note. I won't be able to do it right now because I'm presently streaming. I don't think you can change those things while streaming. But yeah, you know what? That's a good idea, Moosey Boy. So I'll just make a little note for myself. Enable low latency streaming on Twitch. Yeah, I should totally do that. Yeah, I guess because you're noticing the delay with when you do things and when I respond. Sometimes though, that's just because I'm focusing and I don't quite see the chat at the same time. But no, I think you're right. Rename channel to tone generator or register. Okay, now amplitude here. All right, man, have a good evening. It's late for you, eh? Well, thanks for hanging out, Moosey Boy. Maybe by the time you check it out next time, I'll have this digitized speech working. Yeah, so I think what's happening is that when the volume values get written directly into these registers. Yeah. And then right now what I'm doing is I'm grabbing the amplitude register and I do sample channel, and in here, maybe what I need to do here is say, yeah. Would it be like this? Yeah, actually I don't really need plus equals here, do I? Curious. It seems to imply that we should just be using volume. I mean, this is probably incorrect, but I'm just curious if this does anything. Huh. Interesting. Why would the plus equals not have a problem? Oh, because it's interesting. Plus equals ends up working because it's basically saying sample equals to sample plus the float, and then it ends up doing a it's like as if I did this. And then what it does is it says this is an int, this is a float. No, sorry, this is a float and this is an int, and it'll promote the int to a float, I suppose. Anyway. It's kind of annoying. I'm gonna do this a little bit differently. Okay, let's try this. Okay, let's try a spike. Not getting anything there. Okay. Let's see here. Design a vector sample routine of your own. Which draws one vector, play one such a draws other vectors, and so on. I just looked half an hour at the spike code, and I think that's exactly what I just said. They did exactly what I just said. So it is saying that the digitized bytes are going over port A, so that's what would be ending up coming into here. But the question is, where do they end up? Are they directly sent to the volume registers? Let me try something. Case register amplitude A, and I'll just say, yeah, do I really want to be printing this? I don't know. I guess it depends how often it gets printed. Error F. You know what, I'll just show it as a decimal value. I just want to see if it's writing amplitude values during the digitized speech, like the way this document is implying you could do. Interesting. Okay, so let's actually load up Spike. It's interesting actually to see it, how the amplitude registers get written to by the program. So, during the digitized parts, it looks like we were just getting ones. See that darn it there is also digitized speech. And it just says 1. So that means that it's not coming out through the amplitude channels, I suppose. It's writing 1s in there. Okay, let's see if we can figure this out. Vectrex Spike digitized speech. It's not helping me. Let me see here. We have to find some docs on how this works. Speech. Why is this in here? This doesn't look right. knew I found it somewhere, but I just can't seem to locate it. Okay, I wonder if it's more like what's being done is it outputs to the registers for tone and all that, and then rather than those actually going to the chip, they just get stored somewhere and read back. It's not helping me. I'm wondering if they'll have a section on how to do. Nope. You know what? Let's see here. I'm gonna add some more prints. Spike. So these all get a value of 1. Amplitude, tone, noise, all got a value of 1. Fascinating. Could it be these? Okay, let's try something else. Okay, so got our names there. So now that we have that, register. So now I could just do this, remove all this crap. Go register, names, latched address, and value. So now we'll see a bit more in detail what's happening. I'm just doing the break here just so I can put something in here to help me. So that's interesting. In fact, it looked like we were getting just a bunch of ones everywhere. So we're not really getting any writes to any of the other registers. So this means that there's just another direct way to write. And I guess that shouldn't be a surprise. I think that's what I had read. There is, you basically bypass, you disable the sound chip, and there's a way to get values directly to the digital to analog converter. And this must be through the VIA. And that's what I'm not doing right. Something to do in the VIA. Do I have like a note about it in here? So maybe it's this here. Connected to sound output line via divider network. See, this looks promising. Let me bring up that document I have. Where's the one that I was modifying? Here's the mux. Yeah, look here. Sound. This looks like it goes directly. Volume. You see? Channel ABC here. That's the, okay, there you go. The PSG chip does this, or the sound chip can write directly to the volume here from out, whatever this is, 1D, which must be what we're looking at over here. Interesting. Very interesting. And just to check, let's see here. So this comes from the write function. Yeah. And what are we doing here? Port A. So direct write to audio output %D . And then let me disable all the other writes that we had, just because it's going to be noisy. PSG. Oh, look at that. There are the values. Those look like exactly what we want. Okay. So I can kind of cheat this, right? It won't be correct, but if I was to just feed these to the PSG as samples, I wonder if that would just work. All right, let me try and hack this together. It's not correct. Like, we're not actually supposed to go through the PSG here, right? We are really literally supposed to write directly to the audio, but I guess I could do that as well. Let me try and think, how would I do this to model this correctly? So we're doing a write here. Then we have a cycle update in here. And this is where we do the PSG update, where we pass the audio context. We have the audio context available to us here. So we could do something. But right now, the code that does the resampling is in the PSG. Right here. check something else. Okay, so here we get a write from the CPU, and immediately we get a call on the vias update. I think we're always gonna get a single write followed by an update of the via, just the way, because it has to be that way. Okay, let me try this. Let me try and do the resampling directly in the context. See how this works out. Something like this. And then what happens in the PSG is we no longer track these things here. We just say audio context dot add source sample. All this disappears. In the SDL engine, const float star, yeah. Okay. And then here will be samples, size, and then clear samples. Okay. So this so far should get us back to what we already had, except that now I have a way to add samples directly to the audio context, which means I should be able to do it from the via, and it should get resampled correctly. Like this. Okay, so that's still working. That's good. That's a good sign. Now in the via, I definitely don't want to be storing a pointer or anything like that. So maybe we need some kind of, what kind of need? Some kind of flag. What do I do here? Some screen here. Let's do this. Stood optional uint8t, and I'll say sound sample, or direct sound sample. So when this happens, I'll write this here. In fact, I'm just going to assert that it has no value. And the reason for that is because we're going to be consuming the value and clearing it. And this should never happen that we get two writes before getting a chance to consume it. Because of the way the architecture is made, we always get an update per CPU cycle, so it just shouldn't ever happen. Yeah. If I have a direct sound sample, then audio context dot add source sample. I think I can dereference it and then reset it. I think that's right. So let's see if that does the trick. Oh, I think I'm gonna have to remove the my error F here, my printing. Where is it? Done. Be really interesting to see if this actually works. Holy crap, that actually worked. Holy moly. I did not expect that to actually work. I gotta hear it again. I don't know if it's correct, but man, it actually is sort of working. It doesn't sound exactly the same as what we were listening to before. Let me see. Oh, it kind of sounds similar, right? I wish I could do a rewind here. Should like do a capture or something. Oh, actually, I do have a capture. What am I saying? Let me see. Oh, no, that was not the right thing. Sine 16. How do you do how do you like cut everything else? Crop, basically. Trim audio sections, outside selection. There we go. I wonder, is it yeah, I don't know. Is it being affected somehow by the values coming out of the PSG? Well, it's definitely very close. I'm not sure what's wrong with it. I don't know if it's like, I was thinking about the volume thing, you know, like we read that there's a, what am I trying to say here? We are writing direct values here, but that volume, the volume scale that I'm doing, the nonlinear volume scale, is that somehow, it must be getting affected here, right? No, maybe not. just wonder about it, you know. Like, I don't know if the only thing it seems is that maybe it's the volume that's the amplitude of, is supposed to be affected somehow. Am I supposed to detect the different levels and like logarithmically scale it? I don't know. If that's done on the output side, maybe I am supposed to do that. I don't know. Wait. Just had a thought. Wait a minute. Oh, I think I know what's happening here. Yeah, I think my source sound samples are not in the right format. Yeah, I'm supposed to be adding values that are in 0 to 1. That's not what I'm doing here. So let me try this. Why is this even working? Yeah, that's it. It's working just because I'm getting these max values, I guess. Okay, that's much quieter than before. So maybe I'm dreaming here. What are these values looking like? Well, not 0, of course. $48, $160, $48, $160. Oh, maybe they're because they're signed values, maybe. If we ever get 48, 160. But that doesn't matter, even if they're signed. Oh, maybe it does matter. What is it? Does it want? Yeah, okay, no, I think it does matter. Let me try this. If we were to take that, turn it into a signed value, get its ratio, and add 0.5 to it. Because it depends, right? If it's feeding values, plus and minus values for the curve, that could change how it's supposed to sound. I should just make its load spike always. See, it's very, very low, the volume, but I think it's actually more correct now. Yeah, the little bit that I'm hearing. Let's load this up into here and see what it looks like now. We're definitely getting closer. Sine 16. Okay. Okay, this here is okay. Okay, and if we just make this louder, amplify it. I don't know. Let me look again at these values. We're very close. You know what? I'm just gonna store that path to spike. ROM spike here. Spike hoppin'. No, that's not the one. Oh, I don't have spike in here, do I? Anyways. ROMs extracted spike. Debugging. There we go. Now we've got spike loaded. $34. Sample sum 16. See, does this make sense? Maybe I'm getting muddied by what the PSG is doing at this time. Maybe the PSG needs to not add samples. That's possible. Ah, yeah, that's it. That must be it. Maybe I just don't have samples when things are disabled. Is that what it is? Because I have this problem, right, where I have two chips that are generating samples. So if yeah. Okay, we could try this. It'll be a hack, but let me just try something. Let's do this. And it really would be a hack. Basically, we're going to say if we have a direct sound sample, we'll do the add. Otherwise, like we basically ignore updating the PSG while we have direct sound samples. Super big hack, not at all correct. But let's just see if that changes things in terms of what it sounds like. I think I still have that printing, so. Okay, we gotta take out the print. Where was that? Here, error F. Didn't seem to make much of a difference. Maybe I'm wrong about the signed part. Weird. It's like super weird. Let me try. I saw 208. It looked like a big number. Is it really a scale factor problem? Doesn't seem like that's the problem. Oh, wait a minute. So this would be in -1 to 1. So we'd have to actually divide by 2 and then add 0.5. That probably is correct. We'll see. So low. I don't understand. I want to see what these values look like. Yeah, I guess these values are pretty small. Just think for a second. Yeah, no, doesn't make much sense. We should just be able to do a divide by 256. Unless the range, oh, maybe that's it. Maybe the range is only positives from 0 to 128 in this case. I think I've seen that before, right? Oh, we saw 208. That doesn't make sense. I need a bit more info. What if I artificially scale it up? What does that sound like? Let me think. I just find it interesting how it seems to be biased to lower than it is higher here. It's not really centered, the values, which is odd. Or maybe that what we're seeing here is the sampling, my resampling rate is incorrect. Could that be it? Not collecting enough samples. That's possible. But this gets called one. That was interesting. That was a bit louder. So what I'm doing is I'm adding the sample multiple times. This might be more correct because we're definitely not producing samples at the same rate, but if we set the sample and then add it that many times, maybe that'll be closer to the real thing. Now there's still maybe a problem of center point here that I'm not sure. I have to think a little bit about this. See, we're much closer now. That was sounding a lot more interesting. Oops. Okay, this sounds much more correct. Now, I don't know, though, about why it's so offset in the low range, but that just could be the way the samples are authored. I don't know. Doesn't seem right. Let me see here. See, that's pretty loud. Yeah, that doesn't sound quite right. Yeah, I'm getting a little bit tired of it. How's it going, Ella Morchard? Figure you realized I was watching you earlier. Oh, you have a Vectrex. Oh, that's cool. Not too many people who come on here actually have a Vectrex, so it's nice to finally have someone who does. It's a cool machine. I don't actually own this game as well, Spike. It's the only one I know that has digitized voice. There's probably other ones, but it's the one I know for sure that has digitized speech. Mm-hmm. I enjoyed your stream, by the way. It's cool to watch Mozilla hackers. Yeah, my feeling is that the problem here has to do with my resampling and the rate at which it's expected to be fed to the output. Yeah, yeah, I was watching you, and no, it's cool. I love watching people program on stream. It's really cool. I totally obviously support it. I think it's really great. I think it's great for people to watch others program, because it's something that, and I've said this before on stream there, but it's, you know, programming is such a personal thing. You know, we don't really do it in front of others. We typically do it alone. Even at work, you know, there's pair programming, sure, but most of the time people are sitting alone at their desk and they're working, and you only really get to see the finished product from other people, right? You don't see them going through the steps or all the missteps, really, right? All the failures, and I find like watching that part and seeing how even those who you think are so great make mistakes, is kind of, you know, it normalizes, it humanizes the whole thing, and it makes it more accessible. I think it's also inspirational, right? To watch people do things, and you see, like, you know, everyone's the same, right? People just make mistakes, and they look up stuff on Google and Stack Overflow, and they try things and they fail. Like, here I am stumbling through this code, and, you know, eventually I'll get there. But yeah, this is part of the process, and I think it's important to share that. So I don't know if that's part of your motivation, but it is for me. So this is what I'm thinking. I'm thinking that my issue here is, for the sound chip, it's pretty clear. Like, it's pretty clear to me, like, you know, we know in terms of timing that the sound chip has a clock and it's clocking it, and we know all the timings, you know, like, we are basically going to produce a sample every CPU cycle. We know that the chips run at certain rates, and all of that's working. But for the digitized voice, what is the like, what am I trying to say? Like what I've noticed is that most samples are going to the, like most of the samples are being produced at 1/16 of the CPU, the CPU's speed. So does that mean if you want to send digitized voice, you should be respecting that same rate? Now, I mean, all I know is I get these calls, right? There's basically a write that's going to happen to these registers. I guess it's going to be a port A write. And if we get a... Oh, hey, Raining Chain. Hey, man, thanks for the host. Appreciate it. That's really cool. So yeah, so I was saying is basically what's going to happen is that we're going to get these writes that are supposed to go directly to the sound, to the volume here. That's what we're getting right now. We're getting, basically, I haven't actually highlighted it, but because I could. Let's see here. Paintbrush. Basically, this is what we're looking at now. Oh, I had done it differently with alpha or something. Like that. Yeah. So this is what we're dealing with. We're getting values directly out of the mux here. And those, go to here. And I suppose, there was probably some experimentation that was done. Oh, thanks for the auto host, Elm Orchard. I'll pay you back for that too. Been working at home for a bunch of years and finding I need to get out of my head more. This stuff seems like a good venue. Also, for what's worth, I've never worked on an emulator, so it's surprising and neat to see you actually consulting the schematics. Yeah. Well, yeah. It's depending on the kind of information you have available, you'll want to basically look at as many things as possible. For the Vectrex, since it's not the most emulated console out there, and since I also refuse to look at emulator code, I'm kind of limited at what I can look at. So the schematics definitely help to understand. But this is not mainly what I use. I'll be honest. Like if you watch my streams there, this has helped me to understand certain things for sure. But in general, most of the times I'm looking at what do you call them? Like chip documents, right? So documentation all about the chips. Like what I was looking at earlier, like this one, which basically speaks about the chip that I'm trying to emulate for sound there, the programmable sound generator, the PSG as they call it. So it's mostly looking at these data sheets, I guess. Data sheets help a lot. There's some help, like there's a lot of documentation that say developers who kind of reverse engineered the Vectrex to understand how it works. They wrote a lot of useful stuff, mostly for people who want to develop for the Vectrex, but you can get quite a lot out of that. And yeah, so putting everything together, I was able to put this emulator. And really, that was always been my big challenge: is can I get this to work without looking at other emulator code? And so far, I've been able to do that. So that's pretty. It's been pretty fun. I find like I learn more that way, So yeah. So what I was trying to say here was, we've got the CPU, and the CPU now is writing directly. Come here. So there's the CPU over here, the 6809, and it's going to effectively write directly to the VIA over the bus. And then that, if we continue here, yeah, so it writes to the VIA, and the VIA is connected, through this data bus. It passes through the PSG, and it writes to this DAC here, and then this is connected to the MUX. And in fact, let me see here. Yeah, there's some MUX disable stuff here that go through from the VIA. Anyways, effectively, what's happening is that the CPU is writing values directly through the bus that end up on this output here of the sound output here, and these values go straight into the, I guess, the hardware that the digital to analog converter that we hear, so that feeds the speakers, if that makes any sense. Although here it writes volume, which is the one thing that kind of bothers me, and I'm wondering if that's my problem, is if I need to do something, if I need to treat these values and ramp them up along this volume curve. And that's what I kind of was talking about before, because there's a non-linear volume curve there, and I don't know if it's happening here or if it's happening in the sound chip itself. I don't know, it's not clear to me. Like, I don't know what this means. Volume in quotes. Yeah, it's a pretty fun puzzle. So many questions. Because see, now what I've done, so I have the PSG, and I'm saying if I have a direct sound sample, ignore the PSG. But then in between the times maybe I shouldn't clear the sound samples. This is really unclear. I don't know. I don't know how to handle this. We saw that ones were being written. Let me check something. Maybe what we can do is we can find out if the PSG is actually producing samples. That might actually be the trick here. Yeah, I see. Okay, I'm gonna try something. Right now I'm assuming I'm gonna get samples, but maybe I'm not supposed to always get one. mixer control register and tone channel. So mixer control register, that's the pens. I think we could figure all this out here. If one of these is enabled, return true. Okay, now in the via, what we do is we say if the PSG is enabled, and we do this. I don't hear any audio. Let's have a bug in here. Really? What? Really? It never returns true? That doesn't make any sense. Oh, of course. I'm an idiot. Ah, that's funny. That's actually really funny. It can, I have to, it's a chicken and the egg problem. It needs to update to know whether it's enabled or not. All right, that's not really what I want to do. What I want to do is more like figure out whether I should be creating samples. We could do that here. And we'll make it private. Well, that didn't seem to make much of a difference, unfortunately. What? Mm-hmm. Minus 96 gets me a 0.12, 48. See, it says here, digitized samples can be written to the volume registers. Mind that the volume is non-linear. It confuses me when they say volume registers here because they're not talking about these registers. Maybe they are. But anyway, that's not what that's not how spike works, as we saw. But if they mean instead that by volume registers they just mean writing directly to the speakers, then I wonder if this nonlinear thing, because I find it very odd, like that we're seeing values between 48 and minus 96, you know? We get zeros, 48, 160, 48, 160. See, no, sorry, 160 is minus 96. That's it, I keep getting minus 96 and 48. Which is interesting, to say the least. Seems like there's some kind of shift there for the values. We can see it in here. Okay, well, you know what? I'm gonna stop here. I'm gonna let it stew, think a little bit about this. Maybe try and read a bit more, and yeah, we'll get back to this in a couple days. We're definitely really close. I mean, we can hear, you know, we can hear it, right? It's not like we're super far off here. Yeah, we're very close. Hey, thanks, Ellen Orchard. Thanks for watching. So yeah, I should be back on Thursday night, around the same time, around 9 p.m. Eastern time, and we'll keep hacking at this. So guys, thanks a lot for watching, and I'll see you next time.